Dr. M. Ravindran is presently working as a professor in Medical Electronics Department, Savita Engineering College. Prior to his long-standing academic experience with various universities and colleges, he worked across various industries as embedded development and board design engineer with Optodynamics, South Korea, K-Pass Instronic Engineering, and Sigma Circuits. He is an expert in nanoelectronics, nano devices, and robotics with 16.5 years of industrial and teaching experience. Present research interests include performance optimization of semiconductor devices with novel device structure using nanomaterials, superlattice, and micro nanostructures. He has published numerous manuscripts and books chapter in international journals and publishers. He also holds a patent on heterojunction single electron transition with intellectual property rights of India. He is the reviewer for international journals such as International Journal of Electronics, UK, and Journal of Material Science, for Electronics, Springer, Germany. He is also an editorial board member for International Journal of Advanced Research, Ideas and Innovations in Technology of India. Journal of Electronic Research Paper and Application, Bio by World Scientific Publications, Australian and Journal of Matrix Physics and Chemistry, and Press Publishers, US. He is also promoting students towards one semester abroad program in collaborating with US research project with Penn State University and University of Arkansas. He has also motivated students to work on BE project at Plymouth University. He has successfully guided students for various international and national robotic competitions such as NASA's Luna Robotics Mining Competition USA, Singapore Autonomous Underwater Competitions. Dr. M. Ravindran has also received various fellowships from Government of India towards the research attributes such as Indian National Association of Engineer Fellowship to Career Research Work. We are happy to welcome you, sir. You can take over the session.
Thank you very much, Ma. Thanks for the nice introduction and briefing my profile. And outset, I would like to thank Dr. Kanchana for giving me an opportunity to interact with you people on this nice day. So, this session is going to be on the Simulink, and as the previous session was very nicely explained by our Manju ma'am, Dr. S. Manju, and we would start with the Simulink now. And the foremost session would be a presentation of what is Simulink. Then we'll move on into the actual Simulink environment and check some simulations. Can you just confirm if you can see my slides? If not, I will just make sure if it is visible. Is it visible?
Yes, sir.
Yes, sir.
Okay, nice. Okay. So before we start, this session is going to be on modeling and simulation. So can anyone tell me what is modeling and what is simulation? Even if it is wrong, don't worry. Whatever you know, you can share. I really want the session to be interactive, and you don't worry if it's wrong.
Simulation is used to run the program, sir.
Okay. And what is modeling and simulation? Okay. Whatever you said is okay. That's part of correct. But why we do some more simulation? What is the purpose? So
To
say for
get the
example,
output, sir.
yes, exactly. To get the output, but say for example, you want to do something. Okay, you want to make some model, or you want to fabricate something, or you want to do any mechanical model or a electronic model, or you want to make a filter, for example. If you want to make a filter, and before making filter, before going for a fabrication, how would you know whether whatever components you have made to fabricate this filter, or whatever components you used to fabricate this filter is correct or not correct? Or how will you know whether the filter is going to work properly or not? Is it clear? Is my question direct? Is it clear? Can anyone just answer it? See, if you want to fabricate a filter, how will you know whether whatever you used to fabricate a filter is going to work properly or not? Or you are making an amplifier? No answers? Okay. So, say if you really want to make a real-time system, and before you want to check the functionality of a system, you want to make sure whether it is going to work properly or not. You go for a simulation. You go for a modeling and simulation. So that is why we go for a modeling and simulation, and this Simulink is going to support in that perspective. Simulink is part of MATLAB, and this is going to support that perspective. That is what is called as a Simulink. So, in a descriptive term, what is Simulink? Simulink is actually an extension of the MATLAB software, which actually allows the researchers and engineers to build models, and that model would be a dynamic physical system, and it would be a representation of a blocks or a block diagram notation. Okay, so that is why we go for a Simulink. Simulink is something like a drag and drop model. So already the predefined or designed models would be there in the library, and you are going to use those models, and you are going to make a system. So submodels will be available in the library, and with that you are going to make a system. So that is what is called as a Simulink. So for example, if you take the recent plug and play systems, you would have the complete programs as a drag and drop module, and you can use those to make a program in robotics. So similarly here you are going to make a system. It might be any system which is a linear system or a non-linear system, or it may be a continuous time or discrete time component, and sometimes the graphical animations are also possible with the Simulink. So this is what is actually called as a Simulink. So a Simulink is normally a software package which is an add-on with the MATLAB, and it is used for modeling, simulating, and analyzing the dynamic systems. So systems can be multi-rate. That means it can have different parts that are sampled or updated at different rates. So this is what is called as Simulink. Outlay. A Simulink is extension or add-on in a MATLAB software where you actually try to design a dynamic physical systems and run the simulation, check whether the system is working properly or not. So this is what is called as a Simulink software. So if you see here, this is just a process which describes how the Simulink uses mathematical model, and this is represented as a block diagram. So this is just abstract, just to make you understand how it works. So you have physical system, and some parameters would be defined, and that would be identified, and that would be done with the physical model, and then its mathematical model would be defined, and its mathematical analysis would be done. And finally, the predicted versus measured would be compared. And then again, if there is any modifications need to be done when the predicted and measured is having much of a difference, then it goes back to the system model modification, and the process continues until you get the expected result. So this is how the whole process works. And why you need to have Simulink? What is the significance of using Simulink? The potential of productivity improvement and cost saving would be realized from block diagram approach to the programming is dramatic. So based on this, you would have two principles of strategy in Simulink. One would be rapid prototyping, and other one would be rapid application development. So prototyping is a sample system which is made to check whether it works properly. So here this rapid prototyping means with Simulink, with checking the functionality, you would go fabricate your prototype. So this application of productivity tools to develop working prototypes in very less time. So that helps in making your prototypes in minimum time. And here we can optimize the speed, and you can use the find out the memory how much it is used in the complete system, and it also used in hierarchy of physical models used in this space. So basically, Simulink is used in making a prototyping for in a faster rate, and it can be used to check the functionality of a prototype. So that is one. And next one is the Simulink could also be used in rapid application development. So any application would be developed at a faster rate. So that is why we use Simulink here. So here we understand the final computer program is a Simulink model, or it is derived from a Simulink model through a C code generation or automatic C code generation. So as I told you previously, if you take any of these blocks in the library of a Simulink, that would be predetermined and that will have a logic to play, and this would be done by a program. So as Manju ma'am has previously explained about this workspace environment and developing a program, the same way you can actually create a logic in the program, and that can be made as a block, that can be made as a functional block. So that is how the Simulink is going to be very useful. So is the slides changing? Can you see the change in slides?
Yes, sir.
Yes, sir.
Okay. So some important factors, suggestions when you go for a Simulink, you should arrange the blocks and signal lines carefully and make the relation between these blocks easier. And also naming the blocks and signal lines and adding annotations to the model, which can make the purpose of the model element easier to understand. So when you come up with these blocks and you are actually going to connect one block with the other block using the signal lines or wires. So when you do it, try to have a order and try to have annotations and make sure the model name is defined in such a way that when you come back after some time, you will understand how it propagates, how the functional block works. And another best way to make sure that your Simulink block diagram accurately represents your mathematical model equation is write your mathematical model equation directly in your Simulink block diagram, and then compare your results with the actual equation. So as you all know, a program is nothing but a representation of some model, and most of the cases it might be an abstraction of an equation that is made as a program. And here we are actually looking into a program which is made as a block which is having some function. So this is how you can make sure you represent your blocks in a better way in Simulink. So in a normal perspective, a Simulink is a tool for interactive simulation. So Simulink is used to build models from scratch, or you take an existing model and do a add-on to it. So this I will show you an example at the end. For example, if you are going to build an amplifier, you have to actually know the circuit of the amplifier, and you start to build the amplifier circuit from the scratch. From the scratch means you should have the needed resistors, needed capacitors, needed source, and needed output. How you are going to check the output? So you would build it from each component. So you make each of the component and connect it to form as a amplifier. And here Simulink simulations supposed to change the parameters on the fly and see the results immediately. So, say for example, what is on the fly? On the fly means when it is actually functioning. When a system is functioning, if you are able to make the changes, that is what is called as on the fly change. As I stated in the previous example, you take an amplifier and you get an output and you want to improve the gain. Add another amplifier and just input the gain as 1 or input the gain as 2 as a value. What happens? This will actually increase the gain 2 times at the output. So this is an example how you do the on the fly changes. So you will run the simulation and at the same time you just pause the simulation, add a block at the output and get the output of the second block. So that is what is called as an on the fly. And also Simulink gives a sense of fun of modeling and simulation and see what happens. So it's like playing with some software. When you work with the Simulink, it is something like you play with the software, because normally if you take any software, the hardest part is programming, whereas in Simulink you don't need to program, whereas you are going to use the blocks, build a system, run the simulation, see the output. So it is like more of a fun. And Simulink is also practical, which enables thousands of engineers around the world use the model and solve the real problems. And knowledge of this tool serve you well throughout your professional career. So this is actually used by everyone, every researcher or engineers around the world to build different systems. And you can also share whatever you have made, any model you made in this MATLAB central resource where anyone can use your block and run the simulation. And the Simulink block diagram model is a graphical representation of a mathematical model in a dynamic system. Where what is a dynamic system? That is a model generally representing the internal dynamics or memory of the past states, such as integrators or delays or transfer functions or state space models. So mathematical model of a dynamic system is described by the set of equations originally, and that would be made as a program, then that would be used as a block. So this equation is described by a block diagram model, and that might be an algebraic differential or difference equation, and that can be used in your Simulink environment. That block can be used in your Simulink environment. So this is actually a model-based design. So you can move beyond the idealized linear models to explore more realistic models, factoring in fraction, air resistance, gear slipping, hard stops, or any other thing can be described in the real world. So any model of the real time can be defined as a Simulink model, and that can be used for a system modeling, and the simulation can be checked. Any simulation can be checked whether whatever you have designed is working properly or not. So it also provides a GUI, which is a graphical user interface for building models as a block, and then you can actually right click with the mouse and see the parameters of the model what you have designed. So that means when you want to know the model's parameters, you can just click it. You can double click or right click it and see what is the parameters of the design model. So what are the blocks, different blocks available in Simulink? You have different types of blocks in the library. See, like, it may be like sync or sources or linear components or non-linear components or connectors. All these are available in the library. And beyond this, you can also customize your blocks. So customizing your block means you can actually use 2 or 3 sub blocks in this library and make a single block, and you can just make it a name, or you can define it with a name, and you can use it as a customized block. Or if you are well versed with the programming, you can actually do the programming part and define it as a block and use it in the Simulink. So this is how this is model based design is helpful in Simulink. And the model might be a top down model or a bottom up model. So as I've told you, a top down model means you break down a bigger system, go into a smaller system, or a bottom up is you build a bigger system from a smaller system. So as an example, I told you previously, if you want to build an amplifier, you have to build the amplifier with the passive components. So once you make this amplifier, you make it as a block. That is actually a top system or a final system. And you want to look into this system, you go down, go top down. Top down means you just open up the block, amplifier block. You can see the smaller components or passive components inside. So building a component to making a system, building a system from component level is bottom up, and from a system you break down into smaller, it is top down. And you can view the system at high level, and when you double click, you go down to the low level to see what is there inside the block. So that's an example. That's an example what I told you previously. You build a block of an amplifier, double click the block of the amplifier, you can see what is inside. You can see what are the components inside. And you build the block, or you have made this block. How will you see the result? How will you check the functionality? So for that, you have the scopes or oscilloscope, which is called as scope here. And with that scope, you can actually check the simulation results. You can see how the simulation is working, whether the simulation is working properly or not, or your functionality of your block is proper or not. You can check it with the scopes. So now if you get into the Simulink environment, um, if you open this MATLAB software, you can see an icon like this. And when you double click that icon, you will have the MATLAB environment. So this is how your MATLAB environment will look like. So this is the library. And in the library, you have different groups. In each of the group, you have different types of components inside. So if you see commonly used group, you can see you have integrator, you have summing function, you have math function, you have gain, product, sine wave, constant, step response, everything is there. So this is commonly used block. Similarly, each of the block have different types of sub blocks in the library, and you can use any of this block and you can just build a system. So this we are going to do it now in the following session. So if you get into this to create a model, enter the Simulink in MATLAB command window or a Microsoft window, then Simulink library opens, the browser appears, and this Simulink library is going to look like this. And to create a new model, it may be a Unix operating system or a Windows operating system. You can just follow this procedure to create a new model in Unix. Select model from new submenu, and then your library will be visible, and your file menu will show your library. And similarly, if you take a window, you will click new model button on the library browser's toolbar, then you have a new library model window which is like this. That means you will just have a empty clear space, and by clicking the library you can drag and drop the models here. So, for example, if you want to build a simple block, okay, so this is having a sine wave, and the output of the sine wave is given to the integrator, and you have a bus. It is a multiplexing part. From that, you are going to take the output. So, what you will get at the output, you have to get the sinusoidal wave and also a integrated wave at the output. So this is what the block we are going to build today. So this example shows how to build a model using many of the model building commands and actions to build a own model. So this model integrates a sine wave and display the results along with the sine wave and the at the oscilloscope. So the block diagram would look like this, and to create this model, you need to copy the blocks into the model from the Simulink block library. So what you would copy, you in the source library, you will take the sine wave block. In the sync library, you take the oscilloscope block, and in the continuous library, you take the integrated block, and in signal routing, you get the mux block. So once these blocks are visible, you are simply going to drag and drop it in the workspace environment. So if you are going to drag a sine wave from the library, see it is going to look like this. So sine wave from the source window would look like this. So similarly, you can copy the rest of the blocks in the same way, and you can build the own model. Okay, so this is how it looks in the workspace. And when you copy all the blocks, now you have every block inside. You have a sine wave block, you have an integrator block, you have the multiplexer block, and you have the oscilloscope. And how will you connect all this? You connect this with the wires. You have to connect all the blocks with the wires. So you can see here uh, this arrow, inside arrow and exit arrow shows the input and the output. So if you see an angle bracket on the right of the sine wave, you have 2 on the left of the mux block. So that means from here, if you move the cursor towards this mux, it automatically gets connected. Similarly, from integrator, you are going to wire it to the mux. So that means this sine wave and block and the integrator block are going to be connected with the mux block, and this is going to give output at the oscilloscope. So to copy the sine wave from the source library window, open the source library window, double click the source icon in the Simulink library window, then you get it on the workspace. And now we will see the step by step. So what you are going to do, you are going to first position the pointer on the line of the sine wave and the mux block. So you are going to connect the sine wave block on the mux block, and then press and hold the control key, press the mouse button, then drag the pointer to the integrator block, the input port or the over the integrator block that enables the wires to be connected here. So you can see in the second image where the output of the sine wave is connected to the integrator block. So now you have made two connections. One is the sine wave is connected to the multiplexer block. Output of the sine wave block is connected to the multiplexer block. And from the output, you are connecting to the integrator block. The wire is connected from the output to the integrator block. So similarly, you continue with the other blocks. So you do it with the other blocks. You have a final connection like this, and if you want to run this simulation, you need to define the time. So you run the simulations for 10 seconds. So what you have to do set this time, first open the configuration parameter dialog box by choosing the configuration parameters from the simulation menu. On the dialog box, just set the stop time as 10. So 10 seconds. So you can see here the time is set as the 10 seconds. This means your simulation is going to run from 0 to 10 seconds. So once this is done, close the configuration dialog box by clicking OK. So now this Simulink appears something like this. When you run the simulation, you will get the output like this. So now you double click the scope block to open in the display window. Finally, you choose the start the simulation menu, which you have seen the output in the simulation, where you can see one wave is the sinusoidal wave, which is actually the wave from the sinusoidal block, and other wave is the integrated output, where you can see the integrated output as the and next wave. So this is how you actually do the simulation using the Simulink. So let's now look into an example how the same block is built. Uh, is this software environment is visible? Can you see the software, MATLAB software? Guys,
Yes, sir.
is it visible? Okay. So this is I'm actually using 2016 B version of the MATLAB, and this is the environment which ma'am has explained you. And in this environment, if you go to the Simulink, so can you see the cursor?
Yes, sir.
Okay. So you will find a Simulink block here. If you click the Simulink block, the Simulink environment gets opened. So is it visible? The Simulink is visible? Can anyone just confirm me, please? Is Simulink
Yes, sir,
visible?
it's visible, sir.
Okay, good. So now, before we go into building the block, I will show you some examples and different areas where examples are available, or different research areas where examples are available. Yeah. So if you see here, you can see what are the different areas the examples are available. You can see aerospace block set is there, communication systems is there, computer vision toolbox is there, DSP is there, embedded coder is there, fixed point designer is there, HL coder. So you have almost like all the examples which are available in engineering. Almost like every field, the examples are available. And if you take an example here, Simulink, you can see JFET amplifier is available and switched audio amplifier is available. So every block there will be multiple examples available. So if you can actually access our lab, you can run the simulations by yourself. You can just check how the simulations work. So these are all the different blocks available in the Simulink example. Now if we go into our model now, first your environment will be like this. Then you open a blank model. In Simulink, you are opening a blank model. Okay. So you got a empty sheet like environment here. So blank model is available. You can see it, right? Students, can you see the
Yes, sir.
environment? Yeah, fine, good. So once you get into this, you will be seeing an empty sheet. It's an empty sheet. This is where you are going to build the blocks. So you go into this library browser. There will be a library browser where you can just click the library browser, and once you click the library browser, you will see different blocks. You can see aerospace block set, audio system, toolkit, toolbox, communication system, DSP. There are different types of blocks available here. So we are actually looking into the commonly used, recently used block here, and we are going to use what are the blocks we are going to use here? Do you people remember what are the blocks we are going to use here? I showed you an example, right? So what are the blocks? We are going to use sine wave block, integrator block, mux block, and the scope, oscilloscope. So if you take this library, one is sine wave that will be available in the source. So you can take the sine wave here, then just drag it, place it in the workspace. So it is available. It will ask for the amplitude. What amplitude you want? You can give any amplitude. I will give 2 as the amplitude. So this is your source block now. Now you are going to use the integrator and mux. So mux is also available here, and you have scope available here and integrator here. So take the integrator, place it, and then you can define the initial conditions what if needed, and then take the mux block, place it. So you need two inputs. One is from sine wave block, another one is from the integrator block. Then take the scope. This is nothing but an oscilloscope. Place it. And how will you do the connections here? You just keep the cursor of your mouse here. You'll take a wire, just connect it. Similarly, keep the cursor right, just drag it, it will get connected. And here the integrator gets the signal from the sine wave output. Then take the output at the mux and connect it to the oscilloscope. Now you have built the simple model as you have seen here. So you have built the sine wave integrator and the mux block with the oscilloscope. And what is next? What should be done next? Next is you have to check whether this is working properly. For that, you should go click this green button, run. So if you click this green button, run, it will it will start the simulation, and once you see this 100% is completed, that means the simulation is completed. Now how will you see the output? You will see the output by double clicking the scope. If you click the oscilloscope, you get the output. So you will get the two waves here. One is your integrated signal, another one is your actual source signal. Okay. Say for example, if you are not going to use this integrated signal, click it, delete it. Okay. And if you double click it, you just keep one port. You are not going to use two port here. Now you run the simulation. Then you see you get single output here. So you are not getting the integrated output here. Okay. So again, if you want your integration part to be included in the system, then just keep the cursor, connect it, and double click the mux block, define it as two input, or you want maybe three input, define it as three input, then have another integrator, just have two integrators here, then connect this. Okay, now you have two integrated output and one sine wave. Run it. Now just double click the scope, you get the multiple outputs here. Okay, so this is how you run the simulation using the blocks, using the building blocks. Say for example, uh, if you go to this example, so again you just run it, go to example, and you can just see a JFET. So this is your JFET. So this is a simple JFET, and you have the JFET circuit here, and run it. Now you get a output. Okay, so this is your output stage where you get a peak to peak 0.1 amplitude. Okay, say for example, if you want to amplify this, what will you do? You want to amplify this, use a amplifier block from the library. So this is gain. So take and give gain as 2 times whatever input it gets. Then you are connecting at the output, almost at the output, and you have to check both the outputs. You take another scope, connect it at the side. Yeah. So you have slightly modified your circuit where the output is actually improved with a gain of 2. So now you run the simulation. You get an output here. Similarly, you get a output here. So can you see the difference? You have a amplified output here. So similarly, as I told you in the previous slide, you can actually take an existing block and you can modify it. You can modify the existing block. What I have done here is I have just improved the gain. That's it. So your gain is improved here. The same circuit, we have just included an amplifier, then we have improved the gain here. So these are all the simple examples to make or build a system and run the simulation. Similarly, you can actually define anything with the equation, and that equation can be converted into a program, and that program can be made as a block, and that block can be used in the simulation to check the functionality, or that block can be used as part of a bigger system. So this is how the whole Simulink environment will work. So this is an example of running the Simulink model. So that this with this I will end up, and if you have any doubts, please ask me, or else we will end the session. I hope you understood. If you have any doubt, please ask me. Is anyone there?
That was a wonderful mind. That was a wonderful, mind-provoking session, sir. Let me now welcome Dr. D. Kanchana ma'am to felicitate our chief guest. Please, ma'am.
Thank you very much, sir. It was a very good informative session for our students. We'd like to thank Dr. Ravindran for joining us and spending time with us for this introductory session to Simulink. Thank you very much, sir. Kindly accept this as a token of our appreciation.
Thank you, ma'am. Thank you for the opportunity. Thank you very much.
Feedback link will be posted in the chat box. You can fill the feedback form.